I welcome you to the course of Data Structures. My name is Ketan. I completed my post-graduation from IIT Kharagpur and have been working with the product-based company as a developer from last 9 years. I have been also sharing my knowledge to the GATE aspirants and helping them enter into IITs. As a part of this data structure course, I am going to cover the basics of data structures with C and C++ programming language. This data structure course is useful for any programmer, no matter if you belong to the computer science or IT background. The data structure course is useful for all the engineers nowadays. Everyone programs nowadays for their fields. So if you are going to write a program in any language, C, C++, Java or C#.NET, you are eventually going to declare some variables, write some procedures, and while writing the program, many questions come to your mind said that how you are going to store your data in the memory. And the answer is the data structures. Data structures gives us a proper way, a systematic way of storing the data in the memory and retrieving it later. So let's get started with the course. This course is for any programmer who is going to write the program in any programming language. And no matter if you belong to the computer science or any other stream, such as mechanical or civil, if you are going to write any program, you need to first understand the data structures. I have specially designed this course for the GATE aspirants, the engineering students who are going to appear for their semester examinations can also go through my course. And definitely, all the concepts that I am going to discuss are helpful for the interview preparation also. Prerequisites to learn this course is you need the basic knowledge of C and C++ programming language, and throughout the course I am going to use either the C or C++ programs to explain the concepts. Few tips before we jump into the syllabus. The best way to learn the data structures is by writing the programs on your own. So at the end of any concept, you try to write the programs on your own and execute them. And when you write the programs and execute them, to understand your program better and from the memory point of view, you need to debug it line by line. How to debug a program line by line? There are n number of articles you will get on internet. How to debug a program in Linux and how to debug a program in Windows. This is the syllabus I am going to cover as a part of this course, starting with the introduction, in which I am going to first discuss what is the data structures, understanding the memory for your programs, and the static versus dynamic memory allocation for your variables. Followed by the first data structures, that is arrays, in which we learn the one-dimensional array and the two-dimensional arrays. You must have learned the matrix in the mathematics, how to store the different types of matrices in the memory using the 2D arrays that we will learn here. Next data structure is stack, in which we will learn the recursion as well and how to get the prefix and postfix of an expression using the stack. The next data structure is queues. Queues, as you know, is very widely used data structures in many applications. It is one of the important data structures. The next one is the linked list, in which we will learn singly linked list as well as the doubly linked list. Next one is binary trees, in which we will learn how the tree is created, how the binary tree is created, and how to traverse the binary tree using in-order, pre-order and post-order traversal. Followed by one of the type of tree we will learn, which is binary search tree and the AVL trees also. And I'll explain how the binary search trees and AVL trees are useful for any applications. The last concept that we will discuss is the hashing. So the first question is, what is a data structure? The data structure is nothing but an arrangement of the data that programmer is going to define in the memory. So ultimately, every variable that you are going to declare is going to be stored in memory. Now, as a programmer, I should know where my memory is allocated, how I am going to store it, and how I am going to retrieve it. So I say the data structure contains the procedures for storing and retrieving the data from the memory. Every data structure that you are going to define, no matter whether it's an inbuilt data structure or your own data structure, every data structure has a conceptual definition, how it is represented in memory, how it is stored in memory, the operations on the data structure, and the attributes of the data structure. For example, if I take the data structure queues, we know that what are the operations on queue? Dequeue an element from a queue or insert an element in the queue. We call it as a enqueue or dequeue. What can be the attribute of a queue? The front pointer and the rear pointer. We know that if you form a queue at any, let's say a ticket window at airport, and the person standing at the front of the queue gets the chance to do the task. Means there is one attribute associated with the queue, which is front pointer. Similarly, there is another attribute which is called as the rear pointer. In the stack data structure, we have the attribute called as top of the stack. So likewise, we will discuss what are the attributes of the data structures. So before I discuss any data structure, let's say arrays, stack or queues, let us first understand how the memory is allocated for your program. So when you write any program, let's say C or C++, the memory is allocated for the program for execution. And this memory is allocated by the operating system when you execute a program. The memory allocated for the program, or I can call it as a program under execution, more specific keyword is a process. So process is a program under execution. So when you execute a program, the memory is allocated for that program for storing the data. That memory is termed as logical address space. In short, it is also called as LAS. And within this LAS, all the data that programmer is going to define is going to be stored. When I talk about the memory is nothing but the sequence of addresses at which the data is stored. Starting with the first address 0000. So I have considered here the length of the address is 4 bits. So considering the length of the address 4 bits, the first address would be 0000, the second would be 0001 and so on up to 1111. If I think of the decimals, the first address is 0, 1, 2, 3 up to 15. If the length of the address increases, obviously the range of these addresses will also increase. Means the size of this LAS will also increase. These addresses are called as the logical addresses. If you write a program 2 and execute the program 2, the operating system allocates or creates the second logical address space for that program. The first logical address created was for the program 1, in which all the data of program 1 is stored. Now, if you have a second program you need to execute, OS will create the second LAS for the program 2. And the address of the logical address of this LAS also starts with the 0000 ending with 1111. That's why these addresses are called as logical addresses. That are not the actual address at which the data is placed in the physical memory. So if you observe carefully here, the first address in the LAS1 starts with 0 and the first address in the LAS2 also starts with 0. So if you execute 10 different programs, then 10 logical address spaces are going to be created by operating system to store the data of that program. And the range of these logical addresses would be same for all the programs, starting with 0 to n-1. To better understand the logical address, let me take this analogy. Where there are, let's say, 5 students in the computer science engineering and there are 5 students in the mechanical engineering stream. Let's assume that the college defines or assigns the roll numbers to the students, starting with the roll number 1. Now, first student in the computer science has the roll number 1, as well as the first student in the mechanical stream also has the roll number 1. Likewise, the CS students are roll numbered as 1 to 5, as well as the mechanical students are also given the roll numbers as 1 to 5. But what is the differentiation between these two roll numbers? These are the CS students, but these are the mechanical students. So I can call this roll number as a logical address, a logical number assigned to every data or every student of the batch. Let us say there is a seminar organized by the college. There is an open seminar and any student of the college can attend it. Let's consider this is my seminar hall and the students from the computer science and mechanical engineering decides to go for the seminar. Now, if all the students decide to go for a seminar, 2 students will have the same roll number, that is 1 and 1 here. But definitely, when it comes to the seating arrangement in the seminar hall, 2 students, even if they have the same roll number, cannot sit on the same chair. They must sit at the different chairs in the seminar hall. So, this chair number, so every chair will have its chair number, and the chair number is the exact place at which, the physical address at which the student with the logical address number sits. So for every data in the process, so this my CS student is like a program 1 and mechanical students group is like my program 2. And this is my data in the program 1 and program 2. The first data in the program 1, I can say the first variable in the program 1 has the address 1. Some variable from the program 2 has also the address 1. But this is a logical address. And when this data will be loaded in memory, the seminar hall is like the random access memory, your physical memory. When the process or the program is loaded in memory, definitely the operating system will make sure that the 2 data from 2 different processes will not be located or given the space at the same physical memory. They will have the different physical addresses. So I can say the data from 2 different programs can have the same logical address, but definitely they will not have the same physical address. They will have the different physical addresses. And as a programmer, you always need to think of the logical address space only. Why? Because OS is going to hide how this logical address space is going to be loaded in physical memory. It all depends on the architecture of the OS, how OS decides to load the logical address in physical address. So there are concepts in the operating system such as paging, segmentation and virtual memory, which decides how the data is loaded from LAS to PS. So as a programmer, you don't have to worry about how the OS loads the program in the physical memory. But as a programmer, you just need to think of the logical address space. And all the data structures that we are going to learn, that is array, stack, queues, linked list, etc. All the data structures we are going to learn is from the logical address point of view and not the physical address point of view. In my upcoming sessions, I will definitely show you how this logical address looks like for the C++ programs using the Visual Studio tool in the Windows operating system. Now talking about how the data is stored in the logical address space, at one logical address space, only 1 byte is stored. Means if a programmer wants 4 bytes to be allocated for storing some data, it is going to take 4 logical addresses, one for each byte. To understand this, let me take this C example here. I have taken the integer x variable initialized to 5. I want to store the value 5 in the variable x. Now when you execute the program, the logical address space is created by the operating system, and the logical address starts with 0 to n-1. Now assuming that the size of the integer is 2 bytes, to store the value 5, I am going to require the 2 bytes. And what is the binary representation of this decimal 5? Which is 0101. All the remaining are the 0 bits. When it comes to the memory, we know that everything is in the binary format. Now to store these 2 bytes in the LAS, I am going to require 2 addresses. Let's assume that these 2 bytes are given these 2 addresses for storing the data. So here the first address is 0010 and the next address is 0011. So at these 2 memory locations, a single integer, that is 5, is going to be stored. So here is the first byte, all zeros, and followed by the second byte in which the 0101 is stored. So the 2 bytes combining together, I can say that my variable x is stored in the LAS. And what is the address of this variable x? The address of the variable x is 0011. It is the first address of the byte at which your data starts. Now let's see the types of memory allocation. There are 2 types: static memory allocation versus dynamic memory allocation. What is the meaning of static memory allocation? For the static memory allocation, the programmer needs to specify the size of the data or the variables. If the programmer defines the size of the variables, or it knows, then for those type of data or the variables, the static memory allocation will happen. The static memory allocation means before the execution of the program starts, operating system already knows what is the size of that data that it needs to allocate in the memory. Whereas if the programmer do not know the size of the data, means the size is unknown, for that type of data, it is going to be the dynamic memory allocation. For the static memory allocation, the size of the data cannot be changed at runtime. Once it is fixed and decided by the programmer, when that program will be executed, the size of that data won't be changed. Whereas the programmer has a power to decide what will be the size of my data, but not now. At the time of writing program, I don't know that. But at the time of execution of the program, if the programmer needs to give the size as a variable, it can do with the dynamic memory allocation. Now let's look at when this memory is allocated, static versus dynamic. If you define some global variables in your program, then the memory for those global variables is allocated when the program is converted into a process. Means I can say when the execution of program is just going to start, before just operating system starts the execution, the memory for the global variables is first allocated. And then after that, the execution of the program starts. And the memory for such global variables is deallocated when your program is terminated. And about the local variables, you know that you can define the local variables in the function. Now when the memory for those local variables is allocated at the time of execution of that particular function, means I can say when at runtime, when a particular function is invoked, whatever be the local variables present in that function, the memory will be allocated to those variables first, and then the execution of the function will start. And when the function returns to the caller, the memory for those local variables will be deallocated. You see, for the global variables, the memory is allocated only once. And when it is allocated? When the program execution starts. But for the local variables, it's about when that function is going to be called at runtime. If you call a function 5 times, then 5 times the memory will be allocated for those local variables, and 5 times the memory will be deallocated for those variables. So as many times you call a function, those many times the memory is going to be allocated for the local variables. On the other hand, what about the dynamic memory allocation? It is purely in the programmer's hand when to allocate the memory and when to deallocate the memory. So as a programmer, if you know at this point in code I want the memory to be allocated, you can do that. And if you think that after certain piece of code I don't require this data, you can just free out the memory, and that memory will become reusable for storing some other data. So static versus dynamic, the time at which the memory for global variable and the local variable allocated is fixed, whereas here in the static allocation the programmer do not have the flexibility. But whereas in the dynamic memory allocation the programmer has the flexibility of allocation of memory and deallocation of memory. Let's look at the C example to understand the static versus dynamic memory allocation. So as I said, there is a global variable floatx and there is a local variable integer count. So when you execute this program, memory for floatx, that x variable, will be allocated, and when the execution of main function will start, the memory for count variable will be allocated. The memory for the local variable y, which belongs to the function 1, will not be allocated at this point. As of now, I have just allocated the memory for x and count and started the execution of main function. Now while the main function executes, after some time function 1 will be invoked, and the time at which the function 1 will be invoked, at that time the memory for y will be allocated, then the function 1 will be executed, and when the function 1 will return to the caller, that is main function, the memory for y will be deallocated. Now let's talk about the dynamic memory allocation. For doing the dynamic memory allocation, first we have to define an pointer. Here I am defining an integer pointer. It's up to you which pointer you need to define. Why the pointer is required? Because whatever memory is going to be allocated, I need to hold the address of the first byte. And how can I do the dynamic memory allocation? In the C++, you can allocate it with the help of a system call called as malloc function. Malloc function takes an argument which is nothing but the total number of bytes a programmer needs to allocate. So here I am giving, I need to allocate the size of an integer. Whatever be the size of integer, let us say 4. 4 bytes will be allocated by the malloc function. And malloc function is going to return an address. That address type is going to be the void address type. That's why I need to typecast the void address type to the integer address type, because I have defined the count as an integer pointer. Once I get the address of this memory allocated, now you can use this memory with the help of this count variable, and once you are done using the variable, you can deallocate the memory by calling a function free, which takes the address of the first byte, which I have stored in the count variable. Now let's see more about the dynamic memory allocation. Once you allocate the memory dynamically, let's say I allocated 4 bytes here. To use this memory, I say value at that address is equal to 555. Let's look at how this memory allocation looks like in the logical address space. So let's say when you execute the program, for the variable count is a pointer. So for the variable count, let's assume that this memory is allocated. By the way, count variable is just a local variable. So for the count variable, this memory is allocated when the function main is invoked. And during the execution, when the malloc function will be called, malloc function is going to reserve 4 bytes. And out of these 4 bytes, the address of the first byte, that is 0011, will be stored in the variable count. And that's why with the help of this variable count, I can refer these 4 bytes and use it to store the data. So with the help of this value at that address count, so value at the address 0011 is equal to 555, and the 555 will be stored here in these 4 bytes. So the point is, with the help of the pointer, you always access the dynamically allocated memory, and once you are done using this memory, you can just say free out the memory at 0011, means that address. Let me talk more about this dynamic memory allocation. There are 2 ways you can do the dynamic memory allocation. First one is using the function malloc, and other one is the function calloc. Both the functions allocate the memory on the heap section of the process. To learn more about the heap section, you should refer to my operating system videos. Let me tell you in brief what is a heap. Heap is one of the section of process, that is one of the section in LAS in which the memory is allocated dynamically. Both the functions malloc and calloc returns the address of the first byte that is allocated. Let's look at the difference between the malloc and calloc. How to use the malloc function? To the malloc function, we have to pass the total number of bytes you need to allocate. Whereas the calloc function takes two arguments. First argument is the number of elements for which you want to allocate the memory and the size of each element. The calloc function will internally calculate what is the total size by multiplying these two numbers, and then allocation of memory it will do. You as a programmer just need to say, I have to allocate the number of elements and the size of element is the next argument. Once the malloc function allocates the memory, all the bits that are allocated are not cleared out to 0. Means malloc function will only do the memory allocation, and without touching the value present at that memory location, it will just return the address of the first byte. In other words, if you access the memory location from that address, you will get a garbage value. To understand this, I can give you an analogy. Let's say you are buying a second-hand mobile handset from a person X. Now, if you just take that mobile handset and before handing over that mobile to you, person X do not delete the data in that handset. So when you will start using that handset, you will find some irrelevant data in the mobile handset. You as a user have to clear out the data on your own and then start using the mobile handset. Exactly opposite happens in the calloc function. Once the calloc function allocates the number of bytes, it clears out all the bits to 0. Means before the memory is handed over to you, it clears out all the bits to 0. To understand this with the help of analogy, again I can say, if you are buying a mobile from person X, before the person X handovers the mobile to you, the person X will delete all the data from the handset and then it will hand over the mobile to you. And you can straight away start using the mobile handset because there is no data in the mobile handset. So let me explain the difference between malloc and calloc with the help of C or C++ example. So here is the C++ example. To the malloc function, I have passed, I want to allocate the memory for 4 integers. Means I want to store 4 numbers in memory. So instead of declaring 4 integers as int A, int B, etc., what I am going to do, I am going to just say to the malloc, I want to allocate the total 4 into 4, that is 16 bytes. Assuming size of integer is 4 bytes multiplied by 4. If you say you want to allocate memory for 10 variables, just say size of integer into 10. So it will allocate 40 bytes for you and return the address of the first byte, which will be stored in P variable. And once you get the address of the first byte, you can access those variables with the help of this dereference operator. Value at that address is equal to 10. Assume that the address of the first byte is 100. So at the memory location 100, we are going to store the value 10. Next, I want to store the 20 at the next element. But the next element starts not at the 101, but at the 104. Why? because the size of an integer is 4 bytes. So from 100, 101, 102 and 103, these 4 address memory locations are taken by the first element, first integer. So how to get the address of the next element? By just doing the p plus 1. Remember that p plus 1 is not a simple mathematical operation here. It's a scalar arithmetics here. So 100 plus 1 is not 101, but it is 104. Why? Because the size of an integer is 4 bytes. Similarly, p plus 2 will not be 102, but it will be 108. Similarly, p plus 3 will be 112. And once you are done using the memory, you can free up the memory with the help of the free function. Let's look at the program for calloc. So as I said, calloc takes 2 arguments. First argument is the number of elements. So I want to allocate the memory for 4 variables, and the size of each variable is size of int. So that way it will also allocate the 16 bytes and it will return the address of the first byte. And similarly, I can access all these elements with the help of the pointer q here also. And once you are done using the memory, you have to free out the memory using the free function. That's how I conclude this first session of data structures. I have introduced you to what is the data structure, how the memory for the program looks like, that is logical address space, the logical numbers for all the data that you are going to store, and the 2 types of memory allocation, static memory allocation versus dynamic memory allocation. In the next video, we will start with the first data structure, that is the arrays. Thank you for watching the video. If you have any questions, feel free to put in the comment box.